Hello everyone, I hope you're doing well. So for today, we're going to go through this paper of AS level, it's paper 1, variant 2, May June 2025, paper 1 pure math 1. So I'll start with the paper and I hope this helps you understand the questions over here. So the first question is, the diagram shows the graphs of the equations y equals to fx and y equals to gx. Describe fully a sequence of two transformations which transform the graph of y equals to fx to y equals to gx. Okay, so we have to go from y equals fx to y equals gx. Make clear the order in which the transformations should be applied. So we have to go from fx to gx. Okay. Now if you look at fx first, let's take the highest point and the lowest point. The highest point on fx is this and the lowest point is this, right? The distance between these is 3 units. Whereas if you look at gx, this is the highest point, this is the lowest point. The distance between these is 6 units, right? So we can see over here that to go from fx to gx, fx has been stretched vertically, and the distance of the highest and lowest point has become double. So that means that it has been stretched vertically with a factor of 2. So the first thing that has to be done will be stretch with a factor of 2 vertically, or you can say parallel to the y-axis. Or you can also say a vertical stretch with a factor of 2, that would also work. That's the first thing. So if we stretch it vertically, what would happen is when you stretch something vertically, the distance of every point from the x-axis doubles. So let's say that there is this point, the distance of this would double. So right now, let's say this point is 3 units from the x-axis. So after the transformation, this will go to 6 units. Same with this point, this will go to 6 units. And then if we look at the first point, this is at 5, so this would go to 10, which we can't draw over here. But let's just work with these 2 points, which are after we've applied the stretch. So these 2 points have gone above, and we can draw a line between them. And then from here, there will be the graph going like this. So that's after applying the stretch. Now from here, the graph has to come over here. So we need to bring the graph vertically downwards. So this point has to be transformed or translated downwards to this point. Let's see how many units there are that we have to go vertically downwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's a translation, a vertical translation downwards by 14 units. Okay. So 2 is a vertical translation of 14 units downwards. Okay, so that's your first question. I hope this is clear. Moving on to the next one. The question 2 is saying find the coordinates of the point of intersection of the curve and the line with equations given. So here we have a curve, here we have a straight line. What we'll do over here is we'll make y the subject in this equation and then input that in the first equation. So let's work with equation. So let's say this is 1, this is 2. Let's work with 2 first. So to make y the subject, I'll keep y on the left, shift everything else to the right. So y equals to negative 2x, negative 4. Now substitute 2 into 1. So 2xy, so over here we have 1. In place of y, I'll put negative 2x, negative 4, plus 5. In place of y again, I'll put negative 2x, negative 4 squared equals 24. So opening the brackets, 2x times negative 2x will be negative 4x squared, 2x times negative 4 will be negative 8x plus 5. So we have, what we can do is, we can make this a bigger bracket, square bracket with the square. Take negative 1 common, so we'll have negative 1, and then we'll be left with 2x plus 4. Negative 4x squared, negative 8x plus 5. Now we can apply this square on negative 1 separately and 2x plus 4 separately. So we'll have negative 1 squared and we'll have 2x plus 4 squared. So negative 1 squared will become positive 1. We have 5 left. Negative 1 we can remove. 2x plus 4 squared, we'll use the identity a plus b whole square equals to a squared plus 2ab plus b squared. So 2x is a, 2x squared. I'll also write the identity on the right. Okay. So 2x is the same as a, so 2x squared will become 4x squared plus 2ab. So 2 times a times b, which is 4, and then b squared, so 4 squared will become 16. Now opening the bracket, so 5 times 4x squared will be 20x squared plus, so 5 times this whole thing. So first let's simplify this. So 2 times 2x will be 4x, times 4 will be 16x, and then 16x multiplied with 5 will be 80. X plus 16 times 5 will again be 80 equals 24. Now simplifying it, 20x squared and negative 4x squared. So 20 minus 4 will be 16x squared. We have negative 8 and 80. That will be positive 72x. Then we have 80 here, 24 here. Bringing 24 to the left, it would become negative. So 80 minus 24 will be 56. Okay. So dividing everything with 4, taking 4 common, we'll have 4x squared, 72. So 64, then we have 68, 72. 18x plus 14. So we have 4x squared plus 18x plus 14 equals to 0. We can take 2 more common. So 2x squared plus 9x plus 7 equals to 0. Sorry. And then we have 2x squared plus 9x plus 7 equals to 0. So now we'll try middle term breaking over here. We can write this as 2x squared. We can break 9x as 2x plus 7x plus 2x plus 7x plus 7 equals 0. So basically we broke this middle term into 2x and 7x. Now taking 2x common from the first two terms, so 2x common, we'll be left with x plus 1. Taking 7 common from the last two terms, taking x plus 1 common from the whole left side, we'll be left with 2x plus 7 equals 0. So x will be equal to 0 and, sorry, x plus 1 will be equal to 0 and 2x plus 7 will be equal to 0. So x is equals to negative 1, 2x is equals to negative 7, x is equals to negative 7 upon 2. So we've gotten the x values x coordinates of the point of intersection of the curve and the line. Now we need to find the y coordinates. For that, we'll use this equation. So we'll input the x coordinates over here. That will give us the y coordinates. So y equals to minus 2x minus 4. In place of x, we'll put minus 1, minus 4. Y equals to 2 minus 4. Y equals to minus 2. And then y equals to minus 2x minus 4. In place of x, we'll have minus 7 over 2 minus 4. Negative 2 times negative 7 over 2 will be positive 7 minus 4. So y equals to 7 minus 4, which will be 3. So our first point is negative 1 comma negative 2, and second point is negative 7 upon 2 comma 3. I hope this question also makes sense to everyone. Let's move to the next question. So the next question, question 3 is coefficient of x7 in the expansion of this binomial given is 1280. Find the value of the constant p. So first, let's write the binomial theorem. The binomial theorem is PR plus 1 equals NCR times a to the power n minus r times p to the power of r. What does this theorem give to us? So if we have a binomial of this form, okay, a plus b whole power n, so this theorem can be used to find any one of the terms in the expansion of this binomial. So for the first term, the value of r will be 0. For the second term, the value of r will be 1, and so on. Okay? So over here, you need to find the coefficient of x power 7 in the expansion of this. So we know that over here, px power 2 is a, 4x upon p is b, and obviously 5 is n. So we'll replace a and b and n with these values. So we have 5cr times, in place of a, we have px squared power n minus r. In place of b, we have 4 upon px power r. In place of n, we can put 5 over here. Let's simplify this a little bit. So 5cr we cannot simplify. Px power 2 whole power 5 minus r. So we'll divide the powers over here. We'll write p power 5 minus r times x power 2, and then the power on that is also 5 minus r. Okay, then we have 4 power r times x power r upon p power r. Now if you remember the rules of indices, so we have p with this power in the numerator and p with this power in the denominator. So we can bring this p to the numerator and make the power negative. So we'll have p power 5 minus r, and then this p will come upwards. It will become negative r, and then negative r will be added over here. So this will become negative 2r. Same thing we'll try to do with x as well. So if we know that if there's x power 2 and then there's a whole power on that, these two powers can be multiplied. That means that this will become x power 10 minus 2r, and then we'll add this x, the power of this x. So we have x power 10 minus 2r, and then we add the r from here. This becomes plus r. So minus 2r plus r will be minus r. Okay, and then we're left with 4 power r. Now, in the question, they've said that the coefficient of x power 7 is given. So when we need to find the value of r at which the power of x will be 7. So in our binomial theorem, we have that the power of x is 10 minus r. What we need is x power 7. So I'll equate that with x power 10 minus r. If I do that, I can also say, because the bases are the same, so I can equate the powers. From this, I get that r is 3. So I'm looking for the term where r is 3. And remember, as I mentioned, when r is 3, the term will be the fourth term. So what I'm looking for is the fourth term. So I'm looking for T4, and this is when r equals to 3. So basically what I'll just do now is I'll take this expansion and I'll input 3 in place of r over here. So we have 5c3 times p to the power 5 minus 2 times 3. Okay, this dot represents multiplication. Then we have x to the power 10 minus 3, which becomes 7 times 4 to the power of 3. So 5c3 will be 10. 5c3 will be, just a minute. Yeah, 5c3 is 10. Then we have p to the power of 5 minus, so this is 2 times 3, which is 6. 5 minus 6 would mean that it's p to the power of negative 1. And then we have x power 7, and 4 cubed will give us 64. So 64 times 10 will be 640, x power 7 upon p. So I shifted p power negative 1 to the denominator, it became p power positive 1. Right. Now they've said in the question that the coefficient of x power 7 is 1280. What we're getting is the coefficient of x power 7 as 640 upon p. So that means that the coefficient of x power 7, 640 upon p, will be equal to 1280. Now if we try to solve for p, we'll have a line here. So 640 upon 1280 equals to p. So p will be equal to 1 upon 2. I hope this question is clear to everyone. Question number 4. So a point P is moving along the curve with equation y equals to ax power 3 upon 2 minus 12x in such a way that the x coordinate of P is increasing at a constant rate of 5 units per second. Okay. Find the rate at which the y coordinate of P is changing when x equals to 9. Give your answer in terms of the constant a. So we know that y is equals to ax power 3 upon 2 minus 12x. Using this, I can find dy over dx. So for ax power 3 upon 2, to differentiate this, I'll multiply 3 upon 2 with the coefficient. So 3 upon 2a, and I'll subtract 1 from the power of x. This will become x power half. For 12x, it will just become 12, right? Then they've given that the x coordinate of P is increasing at a constant rate of 5 units per second. That means that the change in x with time, the rate of change of x, which is dx upon dt, will be equal to 5, right? Now we can form a chain rule. Dy over dx is equals to dy over dt times dt over dx. Okay, just keep this chain rule in mind always. What we have is dy over dx and dx over dt. What we need to find the rate at which the y coordinate is changing. So we need to find dy over dt. So we'll make that the subject. So shifting dt over dx to the left side, this will become dx over dt equals to dy over dt. So dy over dx. One more thing given in the question is that at x equals to 9. So we can input that in the equation we've gotten for dy over dx. So I'll replace dy over dx with 3 upon 2 a, in place of x, I'll put 9, and that is the power of half, minus 12, okay? And this thing is multiplied with dx over dt, which is 5. This is equals to dy over dt. Okay. So this is 9 to the power of half. 9 to the power of half means that it's cube root of 9, which is 3. So we have 3 here and then we have 3 here, so that's 9 upon 2. So 9 upon 2a minus 12 multiplied by 5. This will be equal to 9 fives are 45 upon 2a minus 12 fives are 60. From here, what we can do is we can take 15 common. This will leave us with 3 upon 2a minus 4. Yeah, that is our dy over dt at x equals to 9. And we have to give the answer in terms of a. That's what we've done. Okay, so in the next part, they've said that given that the curve has a minimum point when x equals to 1 over 4, find the value of a. So we know that at any turning point, whether it be a maximum point or a minimum point, dy over dx is equals to, or the rate of change is equals to 0. So we'll take dy over dx, which we calculated as 3 upon 2 ax power half minus 12. That is 3 upon 2 ax power half minus 12. And they've said that the turning point is at, so this is turning point. They said the turning point or the minimum point is at x equals to 1 over 4. So when we replace x with 1 over 4, we can say that the dy over dx will be equal to 0. Okay, so 1 over 4 is under a square root because the power is half. So 1 over 4 under a square root will become 1 over 2. Okay, we don't have space on the next page. So we have 3 upon 2a times half. This becomes 3 upon 4a minus 12 equals to 0. I'll shift the minus 12 to the right side. So 3 upon 4a equals to positive 12. Shifting 3 upon 4 to the right, a equals to 12 times 4 upon 3. 3 ones, 3 fours. A equals to 16. I hope this question is also clear to you guys. The next question is question 5. The equation of a curve is y equals to 4 cos 2x plus 3 for the domain given 0 to 2 pi. State the greatest and least possible values of y. So first thing to understand, what does this cos 2x mean? So the 2 in cos 2x shows that in the domain of 0 till 2 pi, from 0 to 2 pi, there will be 2 cycles or 2 full cos graphs. That means that if we want to draw a rough sketch of the cos graph, so one cycle, this is the graph, so one cycle would end at pi. That means that the middle point is pi by 2, right? So that means that we have the minimum value at pi upon 2 and the maximum value at pi, because this you can see is the maximum point of the graph and this is the minimum point of the graph. So what they've asked is the greatest and least possible value. For the least value, we have it at x equals to pi over 2. So 4 cos 2 times pi over 2 plus 3. This will be minus 1. And then for greatest, we have the greatest value at x equals to pi. That will be 4 cos 2 times pi plus 3. This will be equal to 7. So the greatest is 7 and the least is negative 1. In the next part, they're saying sketch the curve. So how I like to go about this is with our equation is 4 cos 2x plus 3. So I'll first sketch cos 2x and then I'll apply these two transformations on that. So for cos 2x, as I mentioned, this 2 represents that in the domain from 0 till 2 pi, there will be 2 cycles. So one cycle will end at pi. So let's say that this is, let's mark 1 here and negative 1 here. If the graph starts here, it will end at pi. So at pi as well, it will have positive 1. And at half pi, it will have its least value, which is negative 1. Be 0 at these 2 points. So our graph would be something like this. Okay. And then it will go on. Now, the next transformation, the first transformation we'll apply on it is of multiplying it with 4. This transformation represents a vertical stretch. So with a factor of or scale factor of 4. So each point, the distance of each point from the x-axis will increase 4 times. This point has a distance of 1 from the x-axis, this will become 4. So this is 2, this is 3, this is 4, this is negative 2, negative 3, negative 4. Okay, so the first point will go to 4, 0 will stay at 0, half pi will go to negative 4, 0 at 0, and then last point will also go to 4. Okay. So when we sketch the graph, it will be like this. Now the last thing we have to do is this positive 3. So we have to move the graph 3 units upwards. So let's draw 5, 6, 7. So the first point will go 3 units upwards, it will reach 7. This point will also go 3 units upwards, it will go from 0 to positive 3. So we have 3 somewhere here. From negative 4, the middle point will go plus 3, which will be negative 1. This point will also go 3 units upwards to positive 3, and then the last point will go 3 units upwards to positive 7. So our graph will be the one I'm drawing in blue now. And then we can continue this on the other side. So first draw the points. My bad. So when the graph turns, it goes from here like this. This is the next point, and then it goes like this. This will be 7. I hope this makes sense to everyone. So I applied each transformation step by step. So this was the curve for cos 2x, then for 4 cos 2x, and then for 4 cos 2x plus 3. Next part, hence determine the number of solutions of the equation 4 cos 2x plus 3 equals 2x minus 1. So we have already drawn this graph for 4 cos 2x plus 3. They're asking for the number of solutions when it's equated with this line. So the number of solution means that how many times, graphically the number of solution means how many times will the line and the curve intersect. So what we'll do is we'll try sketching the line onto this graph above and see how many times it intersects with the blue graph. I'll erase all of the other lines that it doesn't get confusing. Okay. So for 2x minus 1 at 0, let's draw it in red. So at 0, we'll have 2 times 0 minus 1, which will be just minus 1. And then for a second point, we can draw the second point at, let's say, when x equals to pi. So at x equals to pi, we'll have y equals to 2 pi minus 1, which is 5.3, 5.28. So at x equals to pi, y will be 5.28 or 3. So pi, this is 5 and this is 6. So 5.3 will be somewhere like this. So I'll sketch a line upwards from pi where these two intersects. That will be pi comma 2 pi minus 1. Now if I draw the line, okay, and we can stretch the line forward. So we can see over here that the line y equals to 2x minus 1 intersects the graph 4 cos 2x plus 3 at 3 distinct points. That means that there will be 3 solutions for the equation that was given over here. That's the graph equals to the line. There are 3 solutions. I hope this made sense. Also, this part is just 1 mark, so you just have to give the answer. You don't even have to draw the graph. That was just to explain it to you guys. Question 6. The diagram shows the curve with equation y equals to 9 upon 5x plus 4 power half and the line y equals to 6 minus 3x. The line and the curve intersect at the point P, which has coordinate as y coordinate 3. Find the area of the shaded region. So when you look at this question, you'll obviously understand that the question is asking for integration over here because we're looking for the area under the curve. Now, how do we go about this? So firstly, they've given that the point P has y coordinate 3. So this point has coordinates x comma 3. Now we know that this point lies on the line given. So replace, we can take this equation y equals to 6 minus 3x, replace y with 3 and find the value of x. 3x equals to 6 minus 3, x equals to 3 upon 3, which is 1. That means that P is basically 1 comma 3. Okay. Now I can divide the shaded area into 2 regions. If I draw a straight line like this, we get a triangle over here, and then we get this shaded region. The triangle has 3 points. The point P is 1 comma 3. This point will be 1 comma 0. This point we can find. This point is where the line cuts the x-axis. If we input 0 in place of y in the equation of the line, we can find the x-coordinate of this point. So y equals to 6 minus 3x. I'll replace y with 0. Okay, so we're getting x equals to 2. So that means that this point is 2 comma 0. This one is 1 comma 0. So now if we look at this triangle that we have, so the height of the triangle will be, so the y coordinate of the triangle, the point P is 3 and the y coordinate of this point is 0. So the height will be 3 units and the base, so this is the x coordinate of this point is 1, the x coordinate of this point is 2. So the distance between these 2 points is 1. The area of this triangle will be half times base times height, which is 3 upon 2. Now we need to find the area under this curve bounded by x equals 0 and x equals to 1. Alright, so I hope you guys have an idea of this shortcut that we use to integrate uh, such functions where there's a bracket and linear function inside that. So for example, let's say that you have y equals to ax plus b whole power n. Okay, and you need to find sorry, and you need to integrate this. So we're integrating y with respect to x. So this would become ax plus b whole power n plus 1 upon a times n plus 1. Alright, and then plus c for the arbitrary constant. So over here we have a similar case. So we have y equals to, we can write this as 9 times 5x plus 4 power negative half, right? So now when we need to integrate this, we need to find integral of y dx, and our limits, over here our limits will be from 0 to 1. So we won't have the constant, we'll have our limits. So I'll move this a bit more forward, 1 and 0. So this will become integral of 9. I can write 9 before the integral because it's a constant. 5x plus 4 power negative half dx. Okay. So now, as you can see over here, we write the same thing as it is, but we increase the power by 1. So we have the same bracket, but the power instead of negative half will become negative half plus 1, which is half, upon, we'll have the coefficient of x and the new power. So 5 times half from 1 to 0. We simplify this, we'll have 5 times half is 5 over 2. This will become 2 over 5 times 5x plus 4 power half from 1 till 0. Now we'll apply the limits. So you can take out 2 or 5 as well from the bracket because it's also a constant. So I can write this as 9 times 2 over 5, and then I start applying the limits. So we have 5x plus 4 power half. First we'll replace x with 1, so that will become 5 plus 4, which is 9 power half, and then we'll replace x with 0, so that will become 4 power half. So we have 9 times 2 is 18 upon 5, 9 power half is 3, and that's 2, so we're left with 18 upon 5. So 18 upon 5 is this region, and the triangular area is 3 upon 2. So we add those two. So area will be 18 upon 5 plus 3 upon 2, which will be 51 upon 10, or you can say 5.1. I hope this makes sense. All right, so question 7 is about proving an identity. So you can see over here, uh, so on the left side, there's only tan, and on the right side, there's only sine and cos. So I'll try to convert the left side to sine and cos as well, using the identity that you all should know about. Tan theta equals to sine theta upon cos theta. So let's get into it. So we're working on the left-hand side. We have tan theta plus 7, so that will become sine theta upon cos theta plus 7 divided by, so tan square theta will become sine square theta upon cos square theta minus 3, right? So the first bracket will become cos theta in the denominator, sine theta plus 7 cos theta in the numerator divided by cos square theta in the denominator and sine square theta minus 3 times cos square theta. To shift the division sign to multiplication, I'll have to take the reciprocal of this. So sine theta plus 7 cos theta on cos theta multiplied with, I'll reciprocate the second fraction. All right. Now what can we do next? So we have sine square theta minus 3 cos square theta in the denominator. So sine theta plus 7 cos theta in the numerator. Okay. One thing we can do is we can cancel out these. So we have cos theta here, and then we can cancel out the square over here. That's the first. That kind of fixes our numerator for us. So now if we multiply the two fractions, so we'll have sine theta cos theta plus 7 cos square theta. So our numerator matches this now. Now we have to work on the denominator. So for the denominator, what I can do is if I add and subtract cos square theta. So I add cos square theta, or in fact, let's just do this. So we have this identity, sine square theta plus cos square theta equals to 1. So I can write sine square theta equals to 1 minus cos square theta, right? So I'll just use that over here. I'll replace sine square theta with 1 minus cos square theta, and then we have minus 3 cos square theta. This becomes sine theta cos theta plus 7 cos square theta on 1 minus 4 cos square theta, which is equal to the right hand side. So proved. I hope this question also makes sense. Move on to the next part. Hence solve the equation sine theta cos theta plus 7 cos square theta upon 1 minus 4 cos square theta equals to this. So over here we know that this fraction that they've given in the next part is equal to tan theta plus 7 upon tan square theta minus 3. Tan square theta minus 3, and this has to be equated with 5 upon tan theta. Let's simplify this. Cross multiplying, so we get tan square theta plus 7 tan theta equals to 5 tan square theta minus 15. Moving everything to the right, so 5 tan square theta minus tan square theta will be 4 tan square theta minus 7 tan theta minus 15. Let's substitute. So let's have a equals to tan theta to simplify it. So we have 4a square minus 7a minus 15 equals to 0. Need to break the middle term over here. So 450s are 60, 512s are 60. Okay. So we can break negative 7a as positive 5a minus 12a. Yeah, minus 15 equals 0. If I take a common from the first two terms, so I'll get 4a plus 5. Negative 3 common from the next two terms, the last two terms, will leave me with 4a plus 5 equals to 0. So 4a plus 5 common now will leave us with a minus 3 equals to 0. This means we have 4a plus 5 equals to 0 and a minus 3 equals to 0. So a equals to negative 5 upon 4 and a equals to 3. So a was tan theta. So we have tan theta equals to negative 5 upon 4 and we have tan theta equals to 3. So if we do theta equals to, so remember the mnemonic ASTC. So in the first quadrant, all sine, cos, tan are positive. In the second quadrant, sine is positive, tan and cos are negative. And it's given over here that our domain is, sorry, 0 till 180. So we'll only have the first two quadrants. So uh, tan theta is positive in the first quadrant. So this value will give us the angle for the first quadrant. And in the second quadrant, tan theta is negative because only sine is positive. So this will give us the value for the second quadrant. Okay, now let's find. So over here we can find the value directly. Theta will just be tan inverse of 3, which is, so remember when you're doing this, your calculator should be in the degree mode. 71.6. That's one of our angles. And then in the second one, so we'll first find the basic angle. So when you're finding the basic angle, you ignore the negative or positive sign, you always take it positive. So we'll have tan inverse 5 upon 4, which will give us 51.3. Because the angle is in the second quadrant, so the second quadrant we do 180 minus alpha, which will be 180 minus 51.3, which will be 128.7. I hope this makes sense. Okay, so question 8 is about circle equation. So over here they've given a circle and they've said the diagram shows a circle with equation given and the line y equals to negative 2. This is the line y equals to negative 2. The line intersects the circle at the points A and B. The center of the circle is C. Find the coordinates of A, B, and C. All right. So for the coordinates of A and B, what we need to do is we need to find the points of intersection of the line and the circle. So we'll input the line equation into the circle equation. So the line equation is given as y equals to negative 2. So we'll input that into the circle equation. So x squared plus, I'll replace y with negative 2, y again with negative 2. All right. Then we have x squared minus 14x. So negative 2 squared becomes 4. Negative 8 times negative 2 becomes negative 16. 8 times negative 2 plus 36 equals to 0. X squared minus 14x. 36 minus 16 would be 20 plus 4 will be 24. So we have this quadratic equation. We need to solve this. Can we break the middle term over here? 12 2s are 24. So we'll have minus 2x minus 12x plus 24 equals to 0. taking x common from the first two terms, taking negative 12 common from the last two terms, taking x minus 2 common. So x minus 2 equals to 0 and x minus 12 equal to 0. So x equals to 2, x equals to 12. Okay. So this means that the coordinates of A will be, y is negative 2, A will be, so A is closer to the x-axis, right? So that has to be x equals to 2, and then B will be x equals to 12. So A will be 2 comma negative 2, B will be 12 comma negative 2. So we found two of them, we need to find one more. So for C, we can look at the general form of the circle equation. So there are two forms. The one that would be closest to what we have over here would be the one that's like this. It's x squared plus y squared plus 2gx plus 2fy plus c equals to 0. So in this equation, the center of the circle is negative g comma negative f. So the equation that they've given to us is x squared plus y squared minus 14x plus 8y plus 36 equals to 0. What I'll try to do is that I'll try to convert this to this form. So x squared plus y squared is perfect. So to convert this, what I'll do is I'll have plus 2 times negative 7x. So if you think about this, if you might open this up, this would become negative 14x as given over here. Then for 8y, I can write that as 2 times 4y is 36 equals to 0. So that means that g for me is negative 7, f for me is g is negative 7. That's weird. Yeah, sorry, my bad. Yeah, that's fine, that's fine. F is 4. So the center of our circle C will be negative g. So negative g is 7 and negative f, so that would be negative 4. So these are the coordinates of the point C. We've got all three A, B, and C. Now moving on to the next part. This part is find the angle ACB in radians. Give your answer correct to three significant figures. It's in radians. First, let's see what's ACB. So connect A and C. And I connect B and C. Then A and B is connected. This is the angle we need to find. The coordinates are 2 comma minus 12 for A. 2 comma minus 2. 12 comma minus 2 for B, and then C was 7 comma minus 4. Now we can easily find the distance A and B, which will be 12 minus 2, that is 10. And we can find the radius. Let's say radius is AC, that will be x2 minus x1, so 7 minus 2 squared. Y2 minus y1, so minus 4 minus minus 2 will be plus 2 squared. So 7 minus 2 is 5, 5 squared is 25, minus 4 plus 2 is minus 2 squared will be 4, the root of 29. This is root of 29. Now what we could do is, if we divide the triangle into half and we apply a trigonometric ratio over here. So our new angle is this smaller angle, which is half of what we need to find. And this distance from A to this midpoint will be 5. So if we apply sine theta, so let's say this is alpha, so sine alpha, that will be opposite, which is 5 upon hypotenuse, which is root of 29. So alpha will be sine inverse 5 upon root of 29 in radians. It's coming as minus 1.19. So angle ACB will be 2 times 1.19, which is 2.38. You need to do this over here, obviously. What you can do is that you draw the triangle over here to show your working. So you draw something like this. A, B, C, you show that this distance is 10. This is what you did. This is the angle. This is root of 29. You show the working for that. And this distance is 5. And then you show the ratio with it. And then multiply with 2 for the final answer. Okay, I'm skipping that part. The chord AB divides the circle into two segments. Find the area of the larger segment. So chord AB divides the circle into two segments. This is one segment, this is the other segment, and they want the larger segment. So they want this area. Okay. So what we can do is that we find the area of the complete circle, we find the area of this sector. Okay. From the area of the sector, or in fact, we can find the area of this sector, all right, and add this triangle to that. Okay. So we know that this angle is 2.38. So if we consider this angle, it will be 2 pi minus 2.38. So I'll first work on large sector. The angle is 2 pi minus 2.38. So 3.90. Okay. And our radius is root of 29. So area will be half r squared theta, that is half root of 29 squared times 3.90. So area will be half times 29 times 3.90, which is 56.60. Okay, that's the large sector. Now for the triangle. So if we look at the triangle has this base which is 10, and then this is the height. So the coordinates of A is y coordinate is -2, y coordinate of C is -4. So that means that this height is 2 and this base is 10, and it's an inverted triangle. So we can write that base is 10, height is 2, so area is half times base times height, so half times 10 times 2, so area is 10. So total area will be 56.60 plus 10, which will be equal to 66.6 units squared. I hope this is clear. Question 9. The equation of a curve is such that d square y over dx square is equal to -24 over x cubed. It is given that the curve has a stationary point at -2, 19. Okay. Find an expression for dy over dx. So when you integrate d square y over dx square, you will get dy over dx. Okay. So we'll first integrate that. So to get dy over dx, first I'll write d square y over dx square in a more simplified form. So I can write this as a -24 x power -3. So when I have to integrate this, I will increase the power of x by 1. So -3 plus 1 will be -2. And I'll divide this by -2. So this becomes 24 upon 2, which is 12 upon, and then I'll also add c because as arbitrary constant. I can simplify this to negative 24 upon negative 2 will be 12 upon x squared plus c. Okay. They've said that the curve has a stationary point at negative 2 comma 19. That means that at x equals to negative 2, dy over dx will be equal to 0. So I'll equate dy over dx with 0, and in place of x, I'll keep negative 2. So 12 upon negative 2 square plus c. I can shift c to the left, so negative c equals to 12 upon 4, negative c equals to 3, c equals to negative 3. That means that dy over dx is equals to 12 upon x square minus 3. Yeah. Now the next part is find the x coordinate of the other stationary point of the curve and determine the nature of this stationary point. So how do we find the stationary points? We equate dy over dx with 0. So 12 upon x squared minus 3 equals to 0. 12 upon x squared equals to 3. 12 upon 3 equals to x squared. So 4 equals to x squared. So x is equals to plus minus 2. The one that we were given in the question was minus 2. So that means that the x coordinate of the other stationary point will be positive 2. And then they've also asked us to determine the nature of this stationary point. So they've given us d square y over dx square already. The equation, the expression for that, that's negative 24 upon x cubed. Negative 24 over x cubed. So for x equals 2, we'll input x in place of, we'll input 2 in place of x. So 2 cubed, this will be negative 24 upon 8. So d square y over dx squared is less than 0, which means that it is a maximum point. I hope this is clear. Part C, find the equation of the curve. Alright, so we've gotten an expression for dy over dx. If we integrate this again, we'll get the expression for the curve. That was now when we integrate this, we'll get y. So I'll first write this simpler form. So now we're integrating that. So we'll increase the power of x by 1, so it will become negative 1 upon negative 1. Minus 3 will become minus 3x plus c. So you can write this as negative 12 upon x minus 3x plus c. We have a point of this curve given, negative 2 comma 19, which we'll put over there. So we'll input this into the equation. So I'll replace y with 19, x with negative 2 plus c. So I'll shift everything to the left except for c. So 19. This would become negative 12 upon negative 2 will be positive 6. So shift that to the left, it will become negative 6. This would also become positive 6. Shifted to the left, it will become negative 6 equals to c. So c will be equal to 19 minus 6 minus 6. So 19 minus 12, which is 7. That means that y equals to negative 12 upon x minus 3x plus 7. Okay, so part D is find the equation of the normal to the curve at the point where dy over dx is equals to negative 9 upon 4 and x is positive. Express your answer in this point. Alright. So dy over dx we got as 12 upon x square minus 3. So 12 upon x squared minus 3 equals to minus 9 upon 4. So 12 upon x squared equals to negative 9 upon 4 plus 3. We take 4 as the denominator, so negative 9 plus 12. 3 upon 4. Cross multiplying, so 12 times 4 upon 3 equals to x squared. We can cancel these out. We'll be left with x squared equals to 16. So x equals to plus minus root of 16. And the question they had said that x is positive. So we will only have x equals to positive 4. Alright, so we found one of the coordinates of the point. That is the intersection of the normal and the curve. For the second coordinate, we'll put x over here. So y equals to negative 12 upon, so x was positive 4, right? So 12 upon 4 minus 3 times 4 plus 7. Y equals to negative 3, negative 12 plus 7. Y equals to negative 15 plus 7 will be negative 8. So the point that we've found is 4 comma negative 8. Now what's this point? This is the point where this normal and the curve meet. Okay. So at that point we also have dy over dx. Now we know that the gradient of the normal will be equal to negative 1 upon dy over dx. So in our case, dy over dx is negative 9 upon 4, so it will be negative 1 upon negative 9 over 4, which is basically 4 upon 9. So we have a point of the line, and then we have the gradient of the line, which is the normal. So we can use these to find the equation of the line. We'll have y equals to mx plus c, so y equals to 4 upon 9 plus c, 4 upon 9x plus c. Substituting this here, so we have negative 8 equals to 4 upon 9 times 4 plus c. So we don't have space over here. So let's try to fit it in over here. So if I shift this to the left side, so I'll have negative 8 minus 16 upon 9 equals c. So 9 as the denominator. 8 times r will be 72, so negative 72 negative 16 equals to c. So c will be equal to negative 72 negative 16 will be negative 88, negative 88 upon 9. So that means that our equation will be y equals to 4 upon 9x minus 88 upon 9. I can take 1 over 9 common, shift it to the left side. This will become 9y equals to 4x. 9y equals to 4x minus 88. Sorry for the lack of space, but I hope this makes sense. Question 10. The first, second, and third terms of an arithmetic progression are these, where k is a non-zero constant. Find the value of k. Okay, so in arithmetic progression, t3 minus t2 will be equal to t2 minus t1. Okay, so we can do 8k minus k squared equals to k squared minus 4k. Simplifying this, shifting everything to the right side, 0 equals to 2k squared. In fact, we can keep, yeah, that's fine.
2k square minus 4k minus 8k will become minus 12k. So shifting 0 over there and everything else to the left. Taking 2k common, so we'll have k minus 6. So we're getting k equals 0 or k equals 6. So if k was 0, that would mean that all three terms are 0, so that's not possible. So k will have to be 6, right? Find the sum of the first 20 terms of the progression. So Sn equals to n upon 2, 2a plus n minus 1 d. This is the formula for sum of an arithmetic progression. We need to find S20. So we have 20 over 2. The first term is given as 4k. 4k will be 4 times 6, which is 24. So 2 times 24. N minus 1 will be 20 minus 1, which is 19 times d. So d is the common difference. So common difference is t2 minus t1. So I can just do it over here. D equals to t2 minus t1. t2 will be k square, which is 6 square, so 36. And then t1 is 4k, which is 4 times 6, so 24. This becomes 12. So d is 12. So this becomes 10. 2 times 24 will be 48, plus 19 times 12 will be 228. 48 plus 228, and then multiplied with 10 is 2760. Part B. The fourth and sixth terms of a geometric progression are 36 and 6. So T4 is 36, T6 is 6. The common ratio of the progression is positive. Find the sum to infinity of the progression. Give your answer in the form of the one that is given. Okay. So this is the general formula for a term in a geometric progression. So T4 would be a r to the power of 4 minus 1, which is 3, so that is 36. And T6 will be a r power 5, which is 6. Okay, so I can say that a equals to 36 upon r cube over here, and then over here a equals to 6 upon r power 5. So I can equate these two. 36 upon r cube equals to 6 upon r power 5. Cross multiplying r power 5 upon r cube equals to 6 upon 36. So this becomes r square equals to 1 upon 6. So r equals to plus minus cube root of 1, so square root of 1 over 6. Now they said that the common ratio of the progression is positive, so it cannot be negative. It has to be positive root of 1 over 6. We have to find the sum to infinity of the progression. So the formula for sum to infinity is a upon 1 minus r. So the first term we don't know right now, so we need to find the first term as well. To find the first term, we can use this. So a is the first term. I know r is 6 upon cube root of 1 over 6 power 5. Putting this into the calculator, this is coming as we'll have to simplify this. Let's first simplify this. So a equals to 6 divided by, so this is basically 1 over 6 power half and then power 5. So we have 1 over 6 power 5 upon 2. And then to make this a multiplication sign, we'll have to reciprocate it. So 6 times 6 power 5 upon 2. So a equals to 6 power 1 plus 5 upon 2, which will be 7 upon 2. Alright, so now we can find the sum to infinity. Sum to infinity is a upon 1 minus r. A is 6 power 7 upon 2 upon 1 minus cube root of 1 over 6. You have to keep it in that form as well. Alright. Okay. So 6 power 7 upon 2, and then we have 1 minus this. Okay, so I can write this as root of 6 power 7 upon 1 minus 1 upon root of 6, right? Now if I multiply root of 6 in both the numerator and the denominator, so what would I get? So numerator, multiplying root of 6 in the numerator, I will get 6 power 7 upon 2 multiplied with 6 power half, which will become 6 power 8 upon 2, which is 6 power 4. So I'll have 6 power 4 in the numerator upon 1 minus, so now we have root of 6 multiplied with this, so 1 times root of 6 will be root of 6, and then 1 over root of 6 multiplied with root of 6 will just become 1. Okay, so our form is 6 power 4 is just 1296, and then we have root of 6 minus 1, and you can compare this to the form that they had asked for. Is the same form. I hope this is clear. I'll just go over this quickly once more. So it was simple till here. Then we had to find a to be able to find the sum to infinity. So I took this equation and I inputted the r that we had found into it. Okay, then there is some simplification. So there is 6 divided by 1 over 6 power 5 upon 2. Making this multiplication, I will have to reciprocate this. So I made this 6 power 5 upon 2 multiplied with 6, that becomes 6 power 7 upon 2. Now this is the formula for sum to infinity. Inputted everything over there. To simplify this, I multiplied and divided by root of 6, which gave me this and just multiplying, just evaluating 6 power 4, I get 1296, and this is the answer that we had to give in this form. Okay, question 11, the last question for this paper. So express x square plus 4x plus 2 in the form x plus a square plus b, where a and b are integers. So this is the completing square form. So the first thing to do for completing square form is that I will take the coefficient of x, because over here x square has coefficient 1, so we don't have to do the first step that we usually do. We'll start from the second step. The second step is that the coefficient of x, take that divided by 2, so divide 4 by 2, you get 2. Now square that and add and subtract. So we divided 4 by 2, we got 2. Square of 2, we have to add and subtract. Okay, so 4 divided by 2 is 2. Square of 2 added, square of 2 subtracted. Now if you look at these first 3 terms, these are in the form of the identity a plus b whole square. The reason is I can write these as x square plus 2x plus 2 square minus, I can simplify this is minus 4 and this is plus 2, so minus 4 plus 2 will be minus 2. Now if you look at the first three terms, this is a square plus 2, this is a, this is b, and then this is b square. So we can write the first three terms as a plus b whole square, which will be x plus 2 whole square minus 2. Alright, that's what they had asked. Then they're saying functions f and g are defined as follows. Fx equals to this, find, and then gx equals to this, find an expression for f inverse x. So when we're looking for inverse of a function, what I first do is I replace fx with y, and then I make x the subject. Alright, so what they helped us in this question is that in the first part they gave us a different form for this expression. So we can write this expression as x plus 2 whole square minus 2. Alright, now we can make x the subject easily. Shifting 2 to the left, so y plus 2 equals to x plus 2 whole square. Now shifting the square on x plus 2, so this would become root of y plus 2 equals to x plus 2. So shifting 2 to the left, so I can say that it's x equals to plus minus root of y plus 2 minus 2. Now what will the inverse be? So the inverse will be minus 2. This will be the inverse. Now we need to decide whether it will be positive or negative. So how do we decide that? So we could do this graphically, or yeah, graphically would be the best method. So let's say that this is let's try to draw a graph for fx. So I'll draw fx using blue. Now fx we know can be written as x plus 2 square minus 2, which means that the turning point is minus 2 comma minus 2. So let's say that this is minus 2 comma minus 2. So, and then it said that the domain is less than or equals to negative 2. That means that the graph of fx will be something like this. Now the inverse is a reflection in the line y equals to x. So the inverse will be, so it should pass through this point. So the inverse will be something like this. All right, so whenever there's a graph of root of x, so the graph is of this shape. Now if it is positive root, then the graph will be above that turning point, but if it is negative root, then the graph will be below the turning point. Now we know from our graphical interpretation of the inverse that the graph for f inverse x has to be below the turning point, which is this point. So that's why over here we'll only take the negative value. I hope that makes sense. This is a bit difficult if you haven't studied this in depth. I can explain this later on in future lessons in more detail. Now the last part, so they're saying find an expression for gf inverse. So first let's find gf. Now f is x squared plus 4x plus 2 and gx is minus x minus 4. So first let's just find gf of x. So we'll replace x by fx. So minus, in place of x I'll put fx, this will become, or should we, will in fact keep fx in the other form, which was x plus 2 square minus 2, and we'll replace that over here. So this becomes minus x plus 2 square plus 2 minus 4. So minus x plus 2 square minus 2. Okay. Alright. So again, to find the inverse, we'll replace gf with y. Then we'll try to make x the subject. To make x the subject, I'll bring this to the left and shift y to the right. So negative x plus 2 square equals to negative 2 negative y. Sorry, this will become positive, and then that's negative 2 negative y. Shifting the square root, so we have x plus 2 equals to negative 2 negative y under a cube root, positive minus, and then we have x equals to positive minus cube root of negative 2 negative y minus 2. Alright, so the inverse of gf will be positive minus cube root of negative 2 negative x negative 2. Now again, we need to be able to decide whether it will be positive or negative. So how do we decide that? Alright, if we again try to draw a simple graph, so if we look at gf, so gf of x is this function over here, which can be simplified to negative x plus 2 square minus 2, right? So again, the coordinates of the turning point will still be negative 2 comma negative 2, which is somewhere here, let's say. So if we draw the graph now, this will be a maximum point because there is a negative sign before the bracket. So the graph would be, and because x is less than negative 2, so the graph will be like this. Alright, and then if we find the inverse of that, so the inverse of this will be, we have to draw the so the inverse will be like this. The reflection in the x-axis will be in the line y equals to x will be like this. So again, you can see that, as I mentioned, this is the graph where there is x in the under root, and this is the part of the graph that is below the turning point, right? So that's why we'll again only consider the negative sign. This will be the inverse of gf of x. I hope this makes sense. Yeah, that was the last question. Inshallah, I'll keep posting more such videos of past papers and topics. If there is any topic or past paper you would like me to cover, then do let me know in the comments. And I hope you got to learn something from this video, and thank you for watching till the end.